Hi there! In today's video, I am going to create this game in C with Raylib. And all of the graphics you see in this game were created with ChatGPT using the DALL-E plugin. So if you would like to see how I built this beautiful game, then make sure to watch till the end, because it did take quite a while to build this thing. 3 hours and 39 minutes to be exact. So I hope you enjoy this video and let's get started. In today's video, I'm continuing a project that I started a few months ago, which is this platform jumping game in C with Raylib. And in today's video, I would like to add some graphics to this game. Now, I have to start again by saying that I am a complete beginner in C and in Raylib and in game development. So this is more like me just sharing my learning experience with C. But let's take a look at what we did last time. So if I'm going to build this project and then I'm going to run it, then here we have my game. And here what I can do is I can move with the arrow keys with this ball, and then with the spacebar I can jump. And of course I can jump and move, and then I can try to get on this other platform, and then I can do this. And I think we also implemented this moving of the camera, so we can actually move in our game world. And we are generating these platforms randomly, which means that now I cannot jump into that one. And I'm not sure what happens if I go here. Absolutely nothing. So it is a very basic beginning of a game. And now I can actually just walk down here. So there's a lot we still have to do. But let's actually check out the code as well, because I don't honestly remember how I did this, because it's been a couple of months. So first we are including just Raylib and standard library and time. And we define this ball as a struct that has a position and a size and a velocity. And then we have a platform that also has a position and a size. Okay. And here we just have a function that creates a random flow. Now, I believe that I have a bit too many of these casts here. I don't necessarily need all of these, but I'm not sure which ones I need. But anyway, it works. And here we have a function that detects if the ball is on a platform. So we pass in the ball, and then we pass in the platforms and the number of the platforms. And then we loop through all of the platforms, and then we check if the ball is colliding with the platforms. So this is the platform rectangle and this is the ball rectangle. And the reason why I made the ball a rectangle in this collision detection is that I don't want the ball to dip down when it's in the end of the platform. I want to just fall off at some point. So we make this rectangle a little bit smaller than the actual ball. And then we have our main function where we initialize the randomness of this application so that we can create the random numbers. And we set the window width and height, and we create the ball, and we set the gravity, and then we create these vectors for the camera offset and the camera target, which I don't quite remember what these actually mean. And then we initialize the 2D camera, and we give it the offset and the target. Okay. And I'm guessing that we move the offset then when we want to move the camera around. Maybe we can use the target if we want to rotate the camera. So the target is like the point from which it is rotated or zoomed. And here we have just some variables that set the spacing of the platforms. And we have the minimum Y position and the maximum Y position. So this is for the random positioning of the platforms. And here in the last video, I used this abs function everywhere, but actually I wasn't supposed to use abs. I wanted to actually convert this into an integer. Now I guess this actually does it, but I wanted to just cast it into an integer. But I'm not sure if I have to do that, since it is an actual integer, so it will be cast automatically. So let's see if we actually get some warnings or something from this, and then we might want to cast them. But I think we don't have to do anything here. At least in these ones that just set it like that. And here we have the width of the world. So basically the width of how long we can walk or bounce through the game. And this is the width of the platforms, and this is how many platforms we're going to create. And we calculate based on the world width. Now, I'm not sure what kind of math I'm using here, but I guess it works. And here we just initialize the array of the platforms, and we add one platform as the floor, and then we add the other platforms. And here we're using this rand float again. And again, I'm going to remove my abs functions, because abs, of course, means absolute number, but this is never going to be negative. So I just want to cast it into an integer. So I'm not sure if I have to do something like int here to cast this into an integer. But let's say if I just omit this, does it do anything? Perhaps in this one it is important because we have other operations in there as well. But in these ones, I don't think it matters. Although maybe I added it because something wrong happened. And again, I don't need to do any of that stuff here. And we initialize the window and we set the target FPS. And here we move the camera offset if we are on the right side of the screen or on the left side of the screen. So if we are over 60% of the screen to the right, then we're going to move the camera to the right. And then if we are 40% on the left, then we move to the left. And then here we make sure that we don't move farther than the beginning of the world. And here we move the ball down by the velocity of the ball. So this is happening in a loop. So every frame we are going to do this. And we add to the velocity the gravity amount. So this is poor man's gravity. So on every frame, the ball will move down faster. And here we check if the ball is on a platform, and we actually return the number, so the index of the platform that we are on. So here we check if we are on a platform, then if we are moving down, so if we have velocity, then we're going to stop the ball. And if we press space when we are on a platform, then we make the velocity negative so that we will jump. And then here we just move the ball left if we press on left, and here we move the ball right if we press right. And here we just clear the background, and then we draw all the rectangles for all the platforms. And then we draw the actual ball. And that's the whole game. So fairly simple. Now, one thing I want to do at first is I want to make this window a little bit bigger, because I noticed in the previous video, the window was kind of small for watching the video on a phone. So I'm going to make it 1000 times 800. Let's see what that will look like if I build it and I run it. Then it's still kind of small. So let's make it 900 and 1200, which is a very weird size. I think because my resolution is kind of weird, or because I have the fractional scaling on to make this screen very big, then for some reason the pixel size doesn't really match what it actually is. But I will make it a little bit bigger even than this. How about that? Okay, that looks pretty nice. I think you can see that. And since we made all of the sizes, or almost all of the sizes, percentages of the screen, then actually everything fits here nicely. Although I think the ball is still the same size. Maybe I used it only on the platforms. So the platforms are like 1% of the screen or something. But let's see. Okay, so we actually have to make some modifications if we want to have a bigger window, because now the ball doesn't jump far enough. So let's do that first. Should we actually have some scale factor? So if we like define scale factor and we say that it's like 1.4, then can we just use the original 800 by 600 and then just do times scale factor? And then we just add the scale factor to everything that needs to be scaled. So the ball size should be scaled by the scale factor. And does the velocity have to be scaled? I'm not sure if this is a good idea, but let's see what happens if we do this. So this is still fine because we are basing the platform min y on the window height, and that is scaled by the scale factor. And these are fine, that should be fine. And here we are using 10 pixels. So this is the height of the floor. So, but this one shouldn't matter because we are actually hiding the floor. So it just has to have some size. So let's leave that as it is. And what else do we have? Maybe that's all. Now the velocity again, maybe it should be scaled by the scale factor. And let's see if that works. If we now build it and we run it, Then we have a bigger ball, but the window is not quite as big as I wanted. And now we're jumping very high. Okay, that seems to work. But we are moving very slowly, so our movement has to be scaled by the scale factor as well. So this one and that one. And maybe I'll make this a little bit less because it jumped very high. And I am going to make the scale factor 1.6 and build it and run it. And now we have a really big window and we can jump, but now it's not jumping quite as high as I would like. So actually I will go back to -30. And let's build it and let's run it. And we actually fell off the floor, and this is because our velocity got too big, and then we jumped straight through the floor before we actually were able to detect that we were on the floor. So I'm going to make the floor like 60 pixels high, and let's build it and run it. Okay, now we can jump on the floor. And we can jump on the platforms and everything seems to be working just fine. So now we can actually get to the idea of this video, which is that I would like to add some graphics to this game, like with actual images. Because now we're just drawing some balls and some platforms, which are just black blocks. So how could we add some graphics? Well, I am not a very good graphical artist, so what I'm going to do is I'm going to use my good friend ChatGPT and the new DALL-E plugin of GPT-4. And I'm going to say, create a design for a platform jumping game with a floor, some platforms, a background, and a character that can jump. So let's see if we can get some ideas for what kind of graphics we could create. Okay, and here are our two images that it created. And these look actually very nice. I especially like the second one. So let's actually download this. But the thing is, we actually want separate pieces of the graphics. We don't just want the image. So let's actually see if I say, can you make a green screen version of the character with 3 different positions? So I want to have like stand, walk, and jump. Maybe we need 2 for walking so that we can actually like move its legs. Let's do walk X2 and let's see 4 different positions. So can it pull this off? So I would like to have just the character. So then I can separate that as its own image. And then we can replace the ball with this character. All right. This is not what I wanted. So it created completely different images, which are cool images, but it's not what we want. So how about we do this? Let's create a new chat. And let's say, create sprites for a platform jumping game character. And should we add like 2D somewhere in here? Because I think the DALL-E model was kind of confused by just saying create images of a character jumping. But if we say sprites, then perhaps it will actually be able to create all of the sprites at once, because I'm sure it is trained for something like this already. Okay, and that's looking pretty nice, but we don't have the whole thing here. But actually, that looks pretty cool. So actually, we would have here the standing version, and then the walking version, and the jumping version, but it is not showing the whole thing. So I'll just click regenerate and see if it does it better this time. All right. And again, it's kind of weird, but let me try one more time. Now I really like the first one it created. And this one is really cool. If I could make this game, it would be really awesome. Now I guess we could just open this in some photo editor and just cut out this character from here. But we only have the jumping version. So let's see what it did now. Okay, now that's actually kind of cool. I'll save this maybe for some other game. Maybe we could make some kind of like Flappy Bird clone, but it's actually a thrusty robot. Okay, let's see. Can we use some of these things? I'll modify this prompt and I will say, can you recreate the second image, but make it a wider aspect ratio image. Because I think it actually can do this, because if you ask it to create a YouTube video thumbnail, it will actually create a different aspect ratio. And how should I say, I want it to be like more, this kind of, it's not like anti-aliased. It's very like pixel art. So what is this? I would say make it smoother and make the sprites smoother. All right, and it actually did it. So now we might be able to use these. Although, again, we don't have the walking version. Make a walking version in the sprite as well. But definitely we can get the standing version from this and then the jumping version. But I want to walk as well. Maybe this one over here could be walking, but it's a little bit too much. This one would be good, but again, it stopped short. And here we have now a completely different character, which I will recreate one more time, because that was a bit too tall. All right, and this looks almost the same. But let's use this one, and let's try to integrate this into our game. So let's go to Photopea, and I'm going to open this in Photopea and extract the characters from this. So let's open this here, and let's use this one as the main image for the character. So let's take this from here, and let's create a new image and paste it here, and remove the background, and then try to remove this white background. And let's actually see how well it removed the background. So if we would have like a red background here, then we do have some sort of glow in there now. Can we control click over here and then do refine it and set some sort of background here? And okay, that's not really doing what I want. Let's just do this. Let's select this area and let's click select and grow, which didn't do anything. So how does refine edge work in Photopea? In Photoshop, it works very well, but this one, why does it leave that? That is very interesting. That doesn't actually make any sense. What would you do with this thing? Tutorial. So is this not the actual image that will result from this? So do I have to do like this, and then I click OK? Then, I guess it's better, but it's not amazing. Anyway, let's try to use this image, because I do not feel like learning to use this application. So I'm going to trim this with the transparent pixels, and I'm going to save this as PNG. And this is standing.png. So let's try to put this character in our game instead of the ball. So how do we do that? Well, right now we have the ball, but we are going to make this an image. So let's check out Raylib.h, and do we have like an image here? Image. Do we have a load image? We do have a load image, so that will return an image. Okay, that's good. So the image will have some data and width and height and whatever is MIP maps and a format. Okay, so let's do this. Let's say that the image character walking is going to be load image, and we are going to load, sorry, this is standing, and this will be standing.png, and let's move from downloads our standing.png into our game. Maybe let's create a folder img and put it there and rename it to standing, and then this will be img/standing. So now we should have an image here. So how do we then put the image on the screen? I guess there will be draw image. There will be no draw image. So how do we put it on the screen? Load image. Okay. So where do we take image as an argument? Can we do this? Image copy, image crop, image mip maps, image resize, image rotate, get image color. image draw pixel. Okay, these are image drawing functions. So is there just image draw? Because these are going to draw inside the image. But here's image draw, which is going to draw a source image within a destination image. But I don't want to do that. I want to just draw an image. Let's see. Load texture from image. Load font from image. Set window icon. Is image ready? Export image. Image copy. Image from image. How do I actually put the image on the screen? Okay, I'm going to have to Google this. How do I draw an image with Raylib? Image drawing. Okay, we are going to say image draw. Draw one image over the other. I don't want to do that. I want to put it on the screen. Okay, we have to use draw texture. So we have to convert the image into a texture. Okay, so here we have it. Load texture from image. So we have to say that texture 2D is going to be character standing texture. And this is going to be load texture from image. Load texture from image. And this will be our character standing. And then we can draw it. So instead of ball, we should have the character. So we are defining the character here, or the ball here. So let's call it character. And it is going to have a position and a size. But now we have to actually have a width and a height for it. So let's do that. And let's find all our balls. Ball on platform. It takes the ball and it takes the rectangle of the ball, which is now going to be ball.x and ball.y. But it's not going to be ball, it's going to be character. Character. And again, width is going to be the actual width. And we probably don't even need to subtract anything. At least not yet. Let's see what this will look like. So this is the collision detection between the character and the platform. So this is character rec. So how do we check the collision? We should only check like the feet, because we want it to be able to jump from below on top of the platforms. So what is the rectangle of the feet of the character? So the x will be the character x minus character x plus 20. Why is this done this way? Let's do this. The x is the character x, and the y is the character y plus character height minus character height times 0.2. And the height will be also character height times 0.2. So this should create a rectangle that is the 20% of the bottom of the character image. So if that is colliding with a platform, then we are on a platform. Okay, that makes sense, I think. And here we have ball again, which we will now create a character. And x is going to be that, that's fine, and y is going to be that. And then we don't have a size, we have a width, and we have a height. And what is the width and height? Let's actually take the properties of this image. Now, this might be too big. So let's see how we can like scale it. So 173,447. 173,447. Okay, and let's find more balls. So here, this will be just character x, and that should be fine. And here, we have to add to the velocity, and we check if character is on platform. That should work just fine. And here, let's make all of these balls as well. I mean, characters, and this one too, character. But now we have character.size, which we don't have anymore. So this detects if the character is moving down, then we set the y position. So if we are on a platform and we are moving down, so we collide with a platform as we're moving down, then we set the y position of the character to the y position of the platform we are colliding with minus character.height. So then we should be on top of it, and we stop the velocity. So that should work. And then instead of drawing the circle, we are going to draw the actual image. So then we can do draw texture, right? And we give it the character standing texture and character dot x and character dot y. And what's a color? What is a color? We can't have a color with this. How did we draw it? Draw texture, color white. What does that mean? Let's put white and see what happened. Maybe this is not the right function. So now everything seems to be fine. So let's try and run this thing and see what happens. Build it, and it compiled. So let's run it, and we got a segmentation fault. So we loaded the file, that's fine. And actually we should do down here, unload image, character standing, but that should not be the problem. If we build it and we run it, segmentation fault. So where does that happen? Let's do some prints here. Printf hello, and let's build it. And we actually don't have our include stdio.h. Really? Was that the issue? Yes. So now if we run it, we don't actually print it. So did we get the segmentation fault here right away? If we build it and we run it, no, still we don't get it. So if we do this and we build it, then we get hello here. So do we actually get segmentation fault from loading an image? That can't be right. At least we don't print the hello. So what if we just exit here, build too few arguments, exit with 0 and run it. Okay, we get the hello. So I don't think the segmentation fault comes from there. So let's do that and run it. Okay, it comes from that one. Load texture from image. So let's see. Here we load texture from image. Actually it says once image has been converted to texture and uploaded to VRAM, it can be unloaded from RAM. Okay, so we could actually unload the image up there already. But again, I don't think this is the issue here. So what is the issue? Let's ask ChatGPT. How do I draw an image from a PNG file in Raylib? Okay, we load a texture. Oh, so we just load the texture directly. Is that true? A load texture, actually, yes. Okay, so then we just draw the texture. But what does the white mean? I really want to know that. Let's see. If we load texture, and we don't have to do this, and we don't have to do that, but this has to be now texture 2D. And then we are going to draw the texture, which we will do down here. So this is just character standing. And I guess we can then do unload texture down here. Character standing. Let's see if this works. So build it and run it. And we have a segmentation fault. Where does that come from? Let's again do printf hello and exit 0. And if we run this, we get a segmentation fault right away. Why? Let's try to do a test. So let's only draw an image. So let's in fact copy this thing and see if it will work. I'm going to say image/standing.png, and let's then gcc o test.c Raylib, and let's run test. And we are not drawing anything, but we did not get a segmentation fault. And again, I wrote this wrong, so it's standing. I'm not sure why I write it wrong every time. Okay, so we are able to draw an image. But what did we do wrong here? Character standing is load texture. Do we need to initialize the window first? Maybe we do this too early. So let's move down here and do it here. Perhaps that's the issue. So let's build this game and let's run it. Okay, now we have an actual character here and we can move it left and right. But of course we should flip the image around and we can jump as well, and we actually jumped over the platform. So that's pretty cool. So now we can jump with this, and it actually works just like with the ball, but we have an actual character. Although now we can't jump. Okay, we can now. So we have some bugs, but yeah, pretty cool. So let's see if we can flip the texture around. Is there like a flip texture, image flip horizontal? How about texture flip rotate? So I guess we can do image flip horizontal. So we can then maybe do this that we were gonna do in the beginning. So we will have the image character standing, and this is going to be load image, and we are going to load image / standing dot png, and then we're going to do character standing texture. It's going to be load texture from image, and then we pass in the character standing here. And then what we can do is we can say character standing left. So I guess we have to do this left. Now this is very long, so maybe this will be character standing img, and then we can drop the texture from this. And this is going to be, of course, right, and this is going to be left. But we are going to use the same image, which is now very long. Maybe I can just say this, and maybe even just stand. And we can use the same image, but then we can do image flip horizontal, the char stand img. So we flip the image, and then we load the left version. And then we can do unload image, char stand image, and this should be a reference to it. So we actually modify the original image. And then what we can do down here is we can, I guess we still have to unload the textures. So it should be char stand right, char stand left. So char stand right and char stand left. And then here we are going to draw char stand right or char stand left depending on what direction we are moving. So if character dot direction is, let's say, -1, then we're going to go left. Otherwise, we're going to go right. So let's do this, and then let's do left. So then when we press left, we're going to say character dot direction is -1. And when we click right, then we say character dot direction is 1. And we can save this direction in the struct. So we can say int direction, just this, int direction. So now it should flip the image when we actually move directions. So let's see. Nothing is happening. So data is not valid to load texture. Okay. Failed to open file. Again, I wrote stadding. What is wrong with my N key on my keyboard? Let's build it and run it. And now we can flip around. So if I go this way, it's going to turn that way. And if I turn this way, it's going to go that way. That is great. And for some reason, we can't jump every time. But yeah, that is starting to work. So let's make it change when we jump. So let's go back to our photo P, and let's take our original image and let's take the jumping version. Which one is a good jump? Probably this one over here. So if I'm gonna take this thing and I am going to copy it and I will paste it here, and I guess we should like kind of align these so the face is in the same place or something, or what should it look like? Maybe like that. And then we have to do image reveal all, and let's again remove the white stuff, and let's do control click, and let's do refine edge again and do the same thing, and then we could do something. I think it kind of matters how we position this image, although I guess we can change that in the code. So let's just do this and let's just trim this thing. Image trim. And let's save it. This is jumping, and let's put it in the right place. So let's copy jumping and put it here. And then we have to load the jumping image, and again jumping left and jumping right. So let's copy all of these things, and this is going to be jump, and we have to unload them here, jump, and then I guess we could add like a boolean jumping. So let's add a bool jumping here to the character, and then when we hit space down here, we set the character jumping to true, and then here we set the character jumping to false. Now I guess we could detect it from the velocity, but maybe it makes more sense to have a separate property here. And then we have to draw a different texture if we're jumping. So let's actually do this. Let's draw a character texture, and then let's just change that. So if character direction is -1, then the character texture will be char stand left. Char texture is that. And I guess we have to initialize it here. So let's do texture 2D char texture. And if we are going to the left, then it's char stand left. Otherwise, it's char stand right. But then if we are jumping, character dot jumping, then we're going to do something else. Now, I think we can simplify this somehow, but let's do it like this first. So if we are jumping, then we are going to use char jump left or char jump right. So let's do this first. So if we now build this and we run it and we jump, if we can jump, then actually it works. But there's something wrong with the jumping, because I'm pressing space, but okay, now it's jumping. That's pretty cool. So let's fix that jumping. So I guess we have some problem with our detection of the pressing of the space bar. So if current platform is not -1, which means that we are on a platform. So for some reason, we are not on a platform even though we are on a platform. So what is the issue here? Is there some like off by 1 pixel error here? Because the character should be on top of the platform. So are we not colliding then? So should I add like +1 to the height? Does that change everything? If I now jump, then it's jumping. And if I jump, okay, I think that was the issue. So now I can jump. And if I turn this way and I jump, then I jump this way. So now I can actually jump. That's pretty cool. But now, of course, this looks kind of weird when we walk. So we should have some sort of animation when we walk. How do we do that? But this is pretty cool. We can jump and we can move forward. Maybe we should move a bit faster, I guess, because it looks a bit weird now. So let's do that. Let's change the speed. So this is the speed. Maybe we should say character.speed. Maybe we could actually have this property in the actual character. So maybe we can actually change it later. Or if we want to have different characters that move at different speeds. So let's add a speed, int speed. And let's add it here. So when we initialize this, we say speed is, let's do 10. And I guess we can use the scale factor here, or I'm not sure where we should use it. I think I left it down here, so let's do that. And let's build it and run it. So now we're moving very fast, which actually looks pretty good when we're jumping, but maybe it's a bit too fast. So let's set the speed to maybe 7 and build and run. And that looks pretty nice. So now we can jump with the character and we can actually jump on these platforms and then we can move, but this looks very weird. So let's try to make it walk. So how does that work? Let's go to our sprites again. And I guess this is kind of a walking thing. So let's copy this and let's again paste it here and let's reveal all and then delete the white stuff and control click and refine edge and OK and trim. And let's save this. I'll call this walk 1. And let's get another walking, because I think we need at least 2 pictures for walking, because it should change like between the frames. So maybe this one. Let's take that. Copy paste. Okay, actually that looks pretty nice. So it will walk like this. So that's good enough. Let's do image, reveal all, and remove the white stuff, and refine edge, and image, trim. And I will save this as walk 2. And let me copy these from the downloads into here. So this one was JPEG now. I was supposed to make it a PNG, so let's do this again. All right, now we have the images here. So we should detect whether we are walking or not. So I guess we again do Boolean walking in our character. And when are we walking? Let's first of all set it here. So let's say that walking is false. I guess we should set the jumping to false as well. I'm not sure if we have to set this. At least we didn't get an error yet from this, but maybe it's a good idea to do this. And then, actually, so we are walking when the key is down. So I guess character dot walking is true here, and it is true here. But before this, we are going to not be walking. So we initialize the character walking to false. So then we're going to know in the end of this frame if we're walking or not. And if we're walking, then we should change the texture again. So let's add another if character walking, and let's make this else if, and let's copy this stuff here again. So this should be now walk. But I think we actually want to check the jumping first, because that should override walking. So if we're jumping, then we are going to be jumping. But if we're walking, then we're going to be walking. And then if we're just standing, then we're going to be here. Okay, so let's then add the walking thing. So actually we have to do walk 1 and walk 2, and everything has to be right and left. So let's create it here. So this is going to be walk 1, and this is going to be walk 1. Did I call it walk 1 or what? Yes. And then we're going to have walk 2. So how do we decide which image we're going to show? So this should be either walk 1 or walk 2. So let's first try if we're going to actually now change to walking when we walk. So let's run it, and in fact we are changing the image. But if we press and hold, then we are just going to slide like this. So that's not great. So I want to change like every 200 milliseconds or something the image while we're walking. So I think there's some like get frame time. I don't remember what these do. So get frame time, get time in seconds for last frame drawn. Okay, that's not what we want. Get elapsed time in seconds since window init. This is what we might want, and it's a double, so I guess we're going to have like decimals in there. So if we say get time, then this is the time in seconds since we started this program. So can't we, based on that, change which one we are drawing? So if we take it here, we say that double time is get time. So this might be something like 25.3. And then if we want to change the image every, I don't know, 100 milliseconds, 200 milliseconds, then I guess we could use like modulo. If we do modulo 2, then it's every other second. But what if we times this by 10, then 25.3 would turn into 253. So then it would be every other 100 millisecond, right? So if we say time is get time divided by or times 10, and can we do this as int, and then we probably have to say double this times that. Do we have to do it? Because when is it going to round this down? Or I guess if we say just double, then we can cast it down here. So if the int of time modulo 2 equals 0, and do we have to even put this in parentheses? I'm not sure. So it actually casts the right thing. So if this modulo 2 is 0, we're going to do walk 1, and otherwise we are going to do walk to. And we're going to do the same thing here. But this is going to be right. So let's see what that does. I'm not that good at math, but it might work. And look at this. We are actually changing, but it looks horrible. So we're like pulsating like this. But my math actually worked. So how should we do this? That's not a good animation for walking, actually. So I think we should have more frames here. So can we add a third frame there? So do we actually have the correct frames here? So if this one over here are standing, then we should move this leg like that, but then we should actually end with this one. So we don't quite have all the frames that we want. But what if we move from this into this into this? So wait a minute. Right now we have these two. This is the standing, then we do that, then we do this. So actually we should have this as walk 1. So let's change this. This is going to be walk 2, and this is going to be walk 1. So now we go from this to this, and then we go, okay, well, we should have one more. So we go to this, and then we go to that. But there should be one in between, right? That's too much. So do we have one in between of those? So we have this one, I guess, and then we have that one. So what is in between of these? That. That's a bit too much. What if we use that one? So let's see again. How does this work? It looks like that. So it walks like this. So that's not a very good walk. I think we should also have one where the other leg is in front. Because now it just moves one leg in front, so it's not going to look like it's walking. Because now we just move this right leg over, and then we're going to move the right leg over again. But are we actually showing that one image in between? Let me do this like, let's not do times 10. Let's just do times 1, and let's run this again. So build it and run it. So now it will look like this. Okay, so we have two different images, but it doesn't quite look like it's walking. So what if I change the timing? So what if this is, I guess, can I divide this by 2, and then it's going to be slower. So if I do this, then it is actually slower, but it still looks kind of weird. I'm not sure if I can solve this issue in this video. I'm gonna have to have more sprites, but it doesn't look horrible. So let's actually try to also add some images for these platforms. So maybe it would look better then. This is kind of funny because it's up there. Maybe we should make this character a little bit smaller. But yeah, now we're walking and we are jumping. And now we are in the end of the world. So if we go here, we disappear. But let's create an image for the platform. So let's try and do this. Let's tell DALL-E to create graphics for a platform jumping game on a white background. I would say completely white background. I need the platforms. They should be jungle themed. Let's see. I'm not sure how to describe what kind of graphics I want. I actually want the kind of graphics that the first image created, so this is what I want. And I really like this character, but let's see. Here we have, okay, not quite what I wanted. So should we actually try and extract the graphics from this image? Or can I use the original image and ask for modifications? So here we have this one. So I am going to change my second prompt, and I will say, can you make a version of the second image where there is just a white background? That's really what I want. Then I can extract these platforms. Let's see if it can do this. And here we have actually a pretty good graphic, and now we have actually the guy here too. Okay, let's download this. And can I now do, great. Now I want you to make the same image, but where the character is just standing. Hopefully it can create that. All right, and in fact we are standing now. That's pretty good. I might be able to extract it from here. Okay, download. What if I say, create the same image, but add a row of walking sprites of the character to the top of the screen. Let's do this. And look at this. They're all the same. Damn it. It's almost good. Make some of the characters stand, some walk, and some jump. Okay, again we have great graphics, but they're all standing. So let's try and regenerate this thing. Alright, and now we have a standing and a walking version, but still just like two images here. So let me first of all take the platform images from this image, and let's continue with that. So let's take this platform from here, and let's put it in a separate file. And again, let's take the white stuff out, and let's refine the edge. And delete the background, and trim it. And I guess we could take another one, for example this, and do the same thing. And I'm going to do this for all of these parts. Alright, and I also took a part of the floor in this image, and I tried to remove all of the extra parts, like these ones and the last block down here. So I came up with this. So hopefully we can use this as the floor, and we can like repeat this. So let's actually see if we get some more space here. Then can we repeat this? If I in fact remove all of this extra stuff from here, then can I repeat this? Does it repeat nicely? Almost. So I'm going to take the beginning of this part and I'll copy it, and I'm going to make a horizontal flip from it, and then I'll move it here, and then I'm going to do something. Maybe I can use the smudge tool to do something interesting here, like move it down a bit so that it would fit properly. Or maybe I can make a mask here and then remove some of this from here to make it smooth. So now, if I cut this at the right spot, then I should be able to copy this, and then if I paste this here and I paste it again, then now these should fit together pretty seamlessly. So maybe there's a little bit of tweaking I should do. So first of all, there should not be a white border here, and maybe this should be just a single color, and that looks a bit weird. So maybe I can smudge it a little bit. And I can remove this part from here. And I can smudge this thing like that, and this thing like that. So then if I trim this, then I should be able to repeat this as the floor. Alright, I have now created two platform images, and I have also created a floor image. Let's see if we can actually use this in the game. So first of all, let's print the floor or draw the floor. So how do we do that? So right now we are just adding one single rectangle as the floor, but this is not going to work unless we can create a background image, which I think we cannot do. So we have to insert separate images as the floor. So right now we have platform count here, and we calculate based on the world width and the platform width, but our images are now at different width. So we are gonna have to think of something. So what is the width of this image? 200 by 166, and this image is 200 by 153. Okay, so platform width might then be 200 pixels, and then the count is this. And what is the floor image width? It is going to be 490. So let's add that here too. Int floor piece width is 490. So let's do platform count plus equals world width divided by floor piece width. So we have to add this many platforms so that we can add the floor as platforms, the floor pieces as platforms. And I guess we want to seal this one. And actually, let's take this as the floor piece count, which is going to be floor piece count is that. So then we can create the floor by using this same kind of for loop as the other platforms. So let's say for int I is 0, I less than floor piece count I plus plus. And we are going to add to the platforms again to index I. So actually I will remove, how should I do this? Can I remove this from here and I will define it here? So then I can use the same I here. Does that make any sense? So I will loop through all the floor pieces and I will add it as the floor x. And int floor x is going to be 0 to begin with. And y will be window height minus the height of the floor. So let's do floor piece height. And let's check what that was. It was 196. And I will probably set it just to 190. So I will crop some from the bottom. And this can be height. So then the y position is going to be at the bottom of the screen. And width is going to be floor piece width. And height is the floor piece height. And for every piece of the floor, we should actually draw the piece. So let's draw texture and let's add floor piece texture. And it is going to be at this x position and this y position and color white. Again, I'm not sure what this means. Maybe it's the background color. So maybe I should say like transparent. Is there transparent? No. But maybe there's like maybe we can set like an alpha. But let's see. Let's make it white for now. And we have to create this floor piece text. So let's create it. So we have to do this, in fact, after we init window. So I guess we can move this up here because we only need the window width and the window height here. So that's fine. And then we can create the floor piece texture. So let's add it here. So this is going to be floor image, and it's going to be floor.png, and this is going to be floor piece texture, and that should be it. We have to unload this one, and we have to unload image, floor image. And let's do this. Down here we are going to unload texture, floor piece texture. And where do we draw the actual platforms? I think we have a function for that. So here. So I should say int I is going to be floor piece count minus 1. So we don't draw rectangles for the floor pieces. Although maybe we want to add to the platform like a type. So then we can decide here based on the type what we're going to draw. And in fact, we have to do exactly that because we cannot draw up here. So let's do that. Let's add to our platform, let's say int type. Now I guess we could define type def enum, and this is going to be platform type. I guess you do it this way, and we're going to have platform, and we are going to have floor. Is that how it works? Or is it this way? No, it's with a comma. Can I have a comma in the end as well? I think I can. So then we can say that this is a platform type. So then when we create a platform, we can set the type. So we say platforms index I type is platform. Sorry, this is floor, or platform floor. What should I call this? Let's just call it floor right now. And then we have to set here this type to platform. So then we have to do this inside of the loop. So down here. So we actually start from 0. And if the platforms index I type is floor, then we're going to draw the floor. Otherwise, right now we're just going to draw the rectangle. Let's see if that works. So let's build it, and we have some errors. Okay, we have to include math. So let's do include math.h and build it and run it. And we have one piece of floor here, but why do we have just one piece? Okay, so did I actually create more than one? Floor piece count. Can I actually do a for loop like this? Should I add it here I++ and remove this one? But is this I going to be this I? Let's see if that does anything. No, we still have one here. Let's try to add here. Oh, sorry. I have to add to the floor X. So I have to do this thing. So we add to the floor X the width of the floor, and that's it. Because we want these to be after each other. So if we do that and we build it, then we have a floor. But now what we should do is we should make it so that we can't draw the platforms on top of the floor. So we can change our minimum Y or maximum Y of the floor. Max Y. Platform max Y is window height times 80. But I'm going to say window height minus floor piece height. Is that what I called it? But I divided it down here, so I have to move these definitions up here. But this one should be here. And I have to subtract from this also the platform height. Do I have a platform height? I don't. So let's define that. Platform height. And that is going to be the height of this image. Although, well, I have to mess with this a little bit, but let me just call it for now. Int platform height is, let's say, 50 pixels. And I do need to use this somewhere. So down here where I am drawing them, then I am going to set the width and the height. Okay, so when I create them, I set the height somewhere here. So it's 5% of the height. So I will just set it now to platform height, which will kind of break our scale factor thing, but never mind. Okay, now we're kind of floating here now because there's some white space in our floor image. So what we should do is we should set the X position of the floor lower than where we draw the image. So let's do this. The Y position of the floor will be window height minus floor piece height plus floor white space. Let's call it floor white space and let's define it here. Int floor white space is something. Let's actually calculate it. So it is around that much, 33 pixels. And then when we actually draw the floor down here, then we can move the Y up by the floor white space. So we draw the image higher, but the actual platform coordinates are lower. So then if we build it and we run it, then now we're actually on the platform, which looks pretty cool. So let's then make the actual platform's images. So let's load the images first. So let's load the floor image, sorry, the platform. So we have platform 1, right? And platform 2. So let's do platform 1 image and platform 1 texture, and let's unload it and let's load the other one, platform 2 image, and then we can do something like this. Let's draw here the texture, but let's unload the textures first. So platform 1 texture and platform 2 texture. And let's leave the rectangle here so we can actually see where the coordinates are. But then let's draw the texture. So platform, let's call it just platform texture. And let's do if I modulo 2 is 0, then platform texture is platform 2 texture. And let's set it first, texture 2D, platform texture is platform 1 texture. So we'll change it for every other one. And then we draw it, at this X and Y position, and let's not do any white space, and let's see if we actually are now drawing the images. We are, but for some reason all of them went down here, which they shouldn't go there anymore. I'm not sure why they go there now. Because we set the maximum Y. Something is wrong with my math. So Y is going to be random float times platform max Y plus platform min Y. Wait a minute. Yes, because this can be 0 to platform max Y. And what is platform max Y? Window height minus floor piece height minus platform height. That should work. Rand float. I wonder if it's because this is a float, but this is an int. So does it already convert this into a float? So do I need to do something like float and this? And this need to be in parentheses. Not quite sure what is happening there. Let's do it again. Still we are pretty low here, which is very weird, but it is creating the images. But now we should make this rectangle so that it will be in the actual right position, because we can now jump on the rectangle, but the image is in a different position. So this probably didn't do anything, so I will remove all those things. And actually I know what is the issue here. So they're always adding the minimum Y here. So we should do what? Should the platform max Y be this minus platform min Y? Because then we are not going to draw it too low. So if we have the game window and our minimum Y is here, so here is the minimum we want to have. This is the topmost position for a platform, so that we can actually fit the guy here. And then this is the lowest point, which is the bottom of the floor or top of the floor. So we want to only draw between these. So if we take a random number from 0 to the maximum position, and then we add to it the minimum platform Y, then if the random position is here, then we're going to draw it too low. But if we pick the random number 0, then it's going to be up here, so we have to add the minimum Y to that. But we have to remove it from the maximum so that we never put it too low. Maybe that is the correct math here. But now we have to do something. First of all, the width needs to be platform width, because right now we have a specific width every time. Did we define platform width already? Yes. So we do that. But then we want to maybe again add some offsets for the images. So these X and Y coordinates need to be the positions where we detect that the platform is, so where we jump on it. But right now, if we build this and we run it, then it is on top. So we need to move it down. And how much do we move it down? Well, it seems like right now it's the height of the platform height, so 50 pixels down. So let's say Y is this plus platform white space. Let's do it like this. And let's define it here. Int platform white space is 50. And if we now build it and we run it, then nothing happened here, because now we have to just draw the image higher. So we have to down here say that the texture will be drawn in the Y position minus platform white space. And if we now build it and we run it, then now it is not quite in the right place. And we have different white space for different platforms. So the other one is kind of fine. So we have to set int white space is platform 1 white space. And then here we set the white space to platform 2 white space. And here we just use white space. And then we find our platform white space and we set it to platform 1 and platform 2. And platform 1, I'm not sure which one is which. So let's make this like 45, and this other one let's make 20. Let's see what that will look like. I still used platform white space somewhere, because I add it here. So I will not add it here at all, because it doesn't matter if I add it here. This is just whatever position we want to have the floor, but then we just move the image that amount. Does it make sense? And it actually seems to look correct now. So now we can jump on the platforms. Now we might want to make them a little bit less wide. So let's do this. Platform width is going to be a little bit less. So let's do 180. And then we are going to draw it again a little bit to the left. So we're going to minus just 20 pixels. or sorry, 10. So if we now run this, then now the area that we detect as the floor is a little bit smaller. So maybe it works a little bit better. So now we drop from here and we drop from... Okay, well, again, we have to fix this too, because now sometimes we can stand like kind of in mid-air. So maybe we need to change the rectangle of the collision detection of this character. So first of all, I'm going to remove these rectangles. We don't want to see them anymore. And I am going to change the character rectangle, be X, character X plus, like, let's actually take a look at the character here. Maybe it can be like 10 pixels, and then the width is going to be minus, let's say, 15 pixels. So now it should work a little bit better. So if we jump here, then actually it looks pretty nice. So it will drop down at that point. So that looks good. But now, of course, our dude is a little bit too big. It doesn't quite fit with the rest of the graphics. So can we make him smaller directly here? I guess we could make the image smaller. Let's make the image smaller, because it doesn't really make sense to have it so big. But I have all of these images. So can I actually do this from the terminal? Convert, resize, 150 times 150, walk1.png, walk1b.png. Is that a good size? That's pretty good. So I will do that for all of them. So let's do walk2, and let's do standing, and let's do jumping. And now we have some new images. So I will remove the old ones. And what is the size of this thing? 58 times 150. So let's update our character. We have the position or the size somewhere. 58 times 150. And maybe that's the only place we have to change it. Where's our character? Sorry, we deleted the files and we have to call it something else. So we have to say B, 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 and B. So build and run. And now it's way too small. Damn it. But yeah, actually it looks kind of better now because we scaled it down, because it was very pixelated before. So let's make it bigger. Let's do this again. All right, now I have again different sizes. So 101 times 260, but I actually have to use the standing version, which is the same. 101, 260. Okay, let's do this. 101, 260. And let's try now, see what it looks like. Okay, that's pretty good. So now I can jump, and we can jump over there, and we can do like this. That looks pretty nice. Maybe it should be now a bit slower again. So let's change the speed to 5. And now it's like this. Maybe let's do 6. All right, so here is our game. We have kind of a walking animation here, which actually I forgot to make faster. So let's remove the divided by 2 from here. And now it's going to look like this. So now we can walk this way, and then we can jump, and we can jump over here, and we can walk again, and it's working. And if we go backwards, then we turn the other way. And if we walk to the end of this thing, then we drop down. And it looks pretty nice. Now, the walking animation is not that great right now, but we can fix that later. But as the final thing, let's add a background to this, because now it's just white and it doesn't look that amazing. So let's add a background, to our platform jumping game. So let's start a new chat. Or maybe we should again modify this question here and say, can you make a wide aspect ratio version of only the background image of the second image? Let's see if we can create that. And maybe we can just create it in another chat to just create some sort of background. Now, of course, the issue here is that we should create a very big image so that we can like walk through the whole world with that. But that looks pretty nice, actually. So I'm going to use this. Let's see if we have enough like contrast between our other parts, other graphics, and this one. So let's get this and let's rename it to background. And this is 3.7 megabytes. How big is this? 1792 times 1024. Can we make it a bit smaller? Convert, resize, 1980 times 1080, and background to background.jpg. So now it's going to be just 700 kilobytes. Okay. Now, in fact, we should resize this to the actual size of the window. Maybe we should do that in the code. Let's see how we can resize images. So let's create the background here. Let's say image, background, image is going to be load image. And we can load from image/background.jpg. And then we can do resize image. And let's actually see how this works. Resize image, image resize. Okay, so we give it the image and the new width and the new height. So background image and the background width and background height. So how do we calculate this? Can we get the dimensions of the image? Image get image dimensions size. Image get image size, image width. How do we get the size of the image? Maybe I will not do this because this video is getting too long. I'm almost 3 hours in. So I am going to just use the background like this. And then I will say texture 2D background image, background texture is load texture background image. And I will unload image, background image. And then I'll unload the texture down here. Unload texture. This one. And sorry, I didn't have to load the image now. Yes, I just do that. Unless I want to resize it later. But let's do this. And let's just slap the image somewhere. And we don't have to unload image anymore. And we're going to do it here. So when we clear the background, then we are going to also draw texture. And the texture is going to be the background image at 0, 0, white. Now we will see what this white actually means. Will everything have a white background? And this is, of course, background texture. So let's see how this now looks. So we are going to build it and we're going to run it. And where is our background? We do not have a background. Did we get some errors? Data format not supported. Image background JPEG. Can we not read JPEGs? That is kind of weird. What if we just take the original PNG and build it and run it? Okay. And we do not have white backgrounds, although the borders are a bit weird. But actually, we now have a background, but it stops here. So how should we fix this issue? Well, we might do something like this. Since we know the background image size, which is 1792, let's put it here. Int background width is 1792. And we know the world width, which is window width times 10. Maybe we can actually move this down a little bit. And then we can do some math here. So we can say int background ratio, maybe this should be float, is world width divided by background width, or the other way. And then when we move the camera around down here, we are going to move the background in the opposite direction based on the ratio somehow. So we actually have to set the X and Y of the background image, or actually just the X. So let's do int background X is 0. And when we draw the background, we draw it at background X. And then what we are going to do is we are going to set the background X to equal maybe the offset X times the background ratio. But this is a negative number, so I'm going to make this a positive number, maybe, times -1, or just minus this. And I'll do the same down here. So in fact, I can do it in just one spot. We can do that. And let's see what that actually does. So now when we move the camera, then we move to the exact wrong direction. So let's change the background ratio to be background width divided by world width. And build it and run it. And now it is still not doing what I want because I am not good at math. So what am I trying to achieve here? If we set the background X to negative camera offset X, then the background will stay like fixed in place, right? Yes, although we have a little bit of a delay there, but now we can go on forever and we are going to have a background. But I want it to move a little bit as we move. So I have to add to this, let's do this. Let's set this to minus the offset X and then background X plus equals, or in fact minus equals background ratio times the background X. Let's see what this does. So now it is still not doing anything. Why is it not doing anything? What is the background ratio now? Does it need to be the other way? I know something has to be divided by something. Background width. So now it moves there, which I want it to do, but not that much. Or is it just that this has to be minus camera offset times background ratio? And does this need to be in parentheses? And if we build and run, no, definitely not like that. Damn it. So here it's pretty good already. So if we do that, then it will be fixed. But what is this? Why does it jump a little bit every time? It is because we move the camera and then we draw. So we have to actually begin the mode after we move the camera. So now if we build it and we run it, then now the background stays in the same place. And if we jump here, it is going to work perfectly. But I do want the background image to move a little bit while we move to the right. So the background should be moving to the left. So that means it should be minus something proportional to the amount that we have moved already. So times the camera offset X minus, because this is going to be negative. So if we do this and then we do background X minus equals background X times 0.01, which is just a made up number, just so that I can see what this will do. Yes, now the background is slowly moving back, but we want a little bit of a bigger number. And the number that I want is such that it would go all the way to the end of the background image when we get to the end of the world. So what is this number? If you put 0.03, then it is going to look like this. Now it's going to move pretty nicely. It's slowly moving backwards. But this is now just a made-up number, so it's not going to actually work. So this we have to calculate from the ratio of something to something. And I think it should be the world ratio or the world width to the background width. But it might be that our world is too big. Let's see how big our world actually is. If we set this to 0.03, then we actually got to the end of the world. So that should be fine. So let's see what is the ratio. Let's do up here, print f, and we are going to give it the background ratio. And let's add here, background ratio is that. So what is that? Background ratio is 7. Okay, so how about the other way? Background width divided by world width. And then we run it. Then now the ratio is 0.000. Wait a minute. So it must be the other way then. So what does 7 mean? It means that there are 7 backgrounds in the world width, right? What is the world width divided by background width? So world width and background width. What does this do? Okay, so background ratio. This is the world width and this is the background width. And it fits there 7 times. So it is like 1 over 7 then. So what is 1 divided by 7? 0.14. So what if our background ratio is this 1 over that? 1 over this. And then we are going to use this here. So this is going to be 0.14. So it's a lot more than this. So let's see what happens. So now nothing is happening. Why not? Did it not do it properly? What if I set it to 0.14? What will happen then? Okay, that actually works pretty nicely if I set it to 0.14. So that is the number we want, but something is wrong with my math. Background ratio. 1 divided by this. Do I need to cast this to float? Because these are integers. Or do I need to cast both of these into floats so that we can actually do this kind of calculation? So now it actually works. Okay, I think my math is finally correct. So now we should get to the end of the background when we get to the end of the world, which is not quite correct. So my math is still off. Damn it. So I have no idea how to solve this thing. Actually, we should also take into account the width of the screen, of course. So in fact, we should have the integer of the background overflow. And this is going to be the background width minus window width. So this is how much we need to move the background in the world width. So do I in fact need to do that? World width divided by background width or background overflow. So let's add this here. And is this 1 over anymore? Let's see what that does. If we build and run, then our background ratio is now 0.04, which seems kind of good because that was very close to what we used at first. So now we do this. So let's see if this works. So now if we move, our background is moving slowly to the left at a different speed than our foreground. So now we should get to the end of the background as we get to the end of this whole world. And it should be exact if my calculations are correct. Now, of course, we can still move the camera too far, as you can see, but actually we should move all the way to the end. So the background should start to become white when this last piece of floor is on the left. So I'm not sure if we can do that. We can, and in fact it works. Okay, so what I can do is I can probably subtract 1 window width from something. So from world width I should subtract window width. So then it should be exactly in the end. So now if I go all the way to the end again, then the background should stop at the same position as the last piece of floor stops. So then it should work perfectly. But then of course we have to change the camera so that we can't go that far, because we shouldn't be able to go that far unless we want to have that sort of effect that we can go in the end. And look at this. So in fact, when we start to go over the world width, then we start to have white background in there. But we shouldn't be able to go farther than like this. So let's do that. How do we calculate that? We already check down here this offset x. If it is greater than 0, then we set it to 0. But we should also say that if it is less than minus world width, then it is going to be minus world width. And I'm not sure if I have to minus one of the window widths from this. Let's see. Trying is the simplest way of doing this. So I'm going to just run this game all the way to the end and see what will happen. Okay, it didn't quite work. So we are now in the end, but we can still go there. So let's do world width minus window width and set it to that. And let's do it again. And we're again in the end, but it didn't work. Damn it. So is it because of the character X? So we should subtract like half of the, or 60% of the window width again. Let's subtract this again. And let's do printf d and let's put the camera offset X. And let's add a new line and let's say offset. And actually I will put this when let's say when I jump, so I can check the number easily. So let's put it here and let's run it. And now if we do this and we jump, then what is the offset now? Wow. Wait a minute. Is that a float? Did I use the wrong thing here? Let's run it again and do this and jump. Okay. So now it's minus 133. So let's go to the end again and see what happens. Okay, so now we are in the end, but we can still move the camera for some reason. So it should stop around here, which is 1752. Wait a minute, why is it not changing it? Ah, okay, so our check is working. So we actually should stop here. We shouldn't get past this point, because if I press space now, it's always 10,752. But we can still move the camera around for some reason. Why is that? It is because I'm changing the mode here. I should change it here. Damn it. So we don't need to do this, but we might have to do this. Let's try one more time. And now if we go all the way to the end, then hopefully it is going to work. Okay, that is a very interesting effect in the end. So actually, that makes me dizzy. When we walk to the end, the camera actually stops, but the background still moves. So we have to change the movement of the background so that we calculate that after we have decided what is the actual camera offset. So this calculation should be down here. And I guess it can be even after the camera. But it wasn't quite correct. Maybe we have to do this minus window width times 0.6, because that is the point at which we are starting to move the camera around. So this is my final test, and then I'll end this video. So if I now go all the way to the end, then it should work perfectly. Now, of course, we can still go over the end with the character and it will fall somewhere. So we should stop it from doing that as well. But I think that will be in the next video. Damn it, it doesn't work. I shouldn't have done this. So if I make this smaller, it's worse. So maybe I need to do 1.4. Why is that? Let's go to the end again. Okay, finally it works now. If indeed this is the end of the floor. So if I go here, I should fall down, but I don't. So maybe this is not quite correct. Yeah, it is not correct. why is there a little bit of extra in there? So if I do that and I run it and I go all the way to the end, then what is that space there? Actually, is it related to this extra platform here? But where does that come from? Oh, did I add to the world width something? So the world width is too wide, or the floor width is not wide enough. So floor piece count is world width divided by floor piece width and the seal of that. But this is again an integer, so I need to convert it into a float so that I can do this. Is that true? So in C, if you divide an integer by another integer, it is going to result in an integer, which is interesting. So maybe now it works. And I might, in fact, as well, stop the character from going to the end of the beginning. So I can say something like, if character.x is less than 0, then character.x is 0. So we can't go off screen to the left. And if character.y is greater than world width minus character.width, then we are going to set the character, sorry, this is x of course, character x. Then character x is going to be this. So now we are constrained in our world. Although undefined reference to symbol seal. I think this is because we have to add to our build.sh lmath, which is interesting that we didn't get this error before. If we build it now, sorry, it's not lmath, it's just lm. If we build it now, then no errors. Okay, so perhaps before we didn't actually need to use a math library because we were dividing integers. Okay, so if I go down here now, I cannot move past this point. And if I go all the way to the end now, then I should not be able to move past the end, and the camera should also not pan past the end. So let's see if that is true. It is in fact true, so I cannot go past this point anymore, and the camera does not follow after that. So that is awesome. So this is going to be the end of today's video. I hope you enjoyed this game development journey in C with Raylib. And if you did, then make sure to subscribe to my channel and give this video a like. And I will see you in the next one.